Hi, my name is Scott. I'm from the Economics Tutoring Center, and today I'm going to be doing an example of hypothesis testing. So please make sure to check my notation and language use with your professor because it may vary. Okay, so today we're doing an example of hypothesis testing. Here's our question. It's a long one. It says, suppose the average quarterly spending on perfumes is $59. In one geographic market, a beauty shop owner wants to show that average spending in that particular market is above the national average. The store owner takes a sample of 25 customers and finds a sample average of 68 with a standard deviation of 15. Find the test statistic and conduct the hypothesis test at the 0.05 level of significance. So usually, the first step when you're doing a hypothesis test is to identify the hypotheses, the null and alternative. So, in this example, I like to think of it as the alternative hypothesis is what you're trying to show typically. So, this owner wants to show that they have that their average is above the national average. So their alternative hypothesis, HA, is that he wants to show that their average is greater than $59, which is the national average. From there, the null hypothesis is always just the opposite. So if it's not greater than $59, their average has to be less than or equal to $59. So those are the hypotheses, and then, like it says, we have to find the test statistic. So, first of all, we need to identify, are we using a t-test or a z-test? And the way you decide that is whether or not the population standard deviation is known. So this question says that the owner takes a sample with a standard deviation of 15. So we have a sample standard deviation. And when that's the case, we want to use a T-statistic or a t-test. So the formula for that is you take the sample average, you subtract the population mean, or in this case that's the national average, and you divide by standard error, which is standard deviation over square root of the sample size. I write S for standard deviation here because it's sample standard deviation. If it were population standard deviation, that's when I would write sigma, like you may be used to seeing. So now we need to identify what some of these numbers are. So X bar is the sample mean, and it tells us sample average of 68. So that's X bar. I sort of mentioned this already, but mu is the population mean or the hypothesized mean. Sometimes you'll see that written as mu 0 in the test statistic formula to indicate that it's the number basically in the hypotheses. So we know that one's 59. S is our standard deviation, which it tells us up here is 15. And N is the sample size, and it tells us that is 25 customers. Okay, so we've identified the key information. So now we can calculate the test statistic. So I'll write the formula down again. X bar minus the mean divided by standard error. And standard error is this whole thing. Standard deviation divided by square root of sample size. So, based on the information we picked out in the last slide, that would be 68 minus 59, X bar minus mu, divided by 15 was our standard deviation, over square root of 25. So 68 minus 59 gives us 9 on top, and then on bottom we have 15 divided by 5, square root of 25 is 5. That gives us 9 divided by 3, because 15 over 5 is 3. and that gives us a test statistic of 3. So the math worked out very nicely in this one. So we're going to have to come back to this. So remember, test statistic equals 3 for now. Now, when you're doing a hypothesis test, you need to compare that test statistic to a critical value, and that's usually written as, well, in this case it will be T sub alpha because we're doing a t-test. We also know it's a one-tailed test because if you recall the alternative hypothesis, it was that their average is greater than 59. Greater than specifies a direction, so it's a one-tailed test. If you have greater than or less than in your hypotheses, it's one-tailed. If your hypotheses are equal to or not equal to, then it's a two-tailed test. Okay, so our critical value is denoted by this T sub alpha here. And to do that, you look on the T table. And I won't go through how to use that exactly, but if it's a one-tailed test, okay, we know our alpha is 0.05 because it tells us here 0.05 level of significance. Because this is a one-tailed test, you will not divide alpha by 2 when you're looking at the t-test, so you do not do that. The other thing you need when finding a critical t-value is degrees of freedom. That is equal to the sample size minus 1, so in this case it's 24 since our sample size is 25. So if you cross-reference those numbers on the t-table, you'll find that the critical t-value is 1.711. Okay, so if you recall from before, we found that our test statistic was 3. Our critical value using the t-table or a calculator was 1.711. And I'll just remind you what the alternative hypothesis was, is that the store owner's average is greater than the national average of 59. And now that we've found all these numbers, we can make conclusions about this test. So the decision rule for a right-tailed test like this one, and it's right-tailed because of our alternative hypothesis includes greater than. So the decision rule is that if your test statistic is less than your critical value, you fail to reject the null hypothesis. On the other hand, if your test statistic is greater than or equal to your critical value, you reject the null hypothesis. So if we look at our test statistic and critical value up here, 3 is greater than or equal to 1.711, so we can reject the null hypothesis. And if you recall from before, the null hypothesis is that the store owner's average is less than or equal to the national average. So the fact that we reject this null hypothesis means that we found statistically significant evidence that the store owner's average is greater than the national average. So we found evidence in favor of the alternative hypothesis. And that's how you conduct a t-test. Okay, so that was our example today for hypothesis testing. If you have any further questions, please feel free to come into the tutoring center or ask your instructor.